Hello, everyone, and thank you so much for joining. You're here for today's demonstration of the Geonexus Integration Platform, connecting multiple enterprise systems. My name is 𝐂𝐚𝐬𝐞, and I'm a marketing coordinator here at Geonexus. And as usual, I brought in Josh Swenson, the VP of Revenue Operations, to help answer some of the questions you may be having after the end of the demonstration today. Today we'll be showing a recorded demonstration of Amelia, one of our software implementation leads, walking you through two different use cases demonstrating just how easy it is to connect multiple enterprise systems using the Geonexus Integration Platform. The first use case goes over a quick platform overview showing an example configuration set up for a water utility looking to keep their data synchronized as they transition from Esri's geometric network to the utility network. The second use case highlights the same water utility looking to integrate their Hexagon EAM system with data that is housed within a SQL database. Before we dive into the demonstration today, I'm going to take a few minutes to set a quick foundation of who we are for those of you who may not be familiar with Geonexus. Geonexus is a software company, and really for the last 13 years, our focus has been on simplifying enterprise integrations for utilities across the globe. To help illustrate what Geonexus does, I want to quickly use this slide to talk about the evolution of integrations for the organizations that we serve. Almost every organization we talk to these days is looking to integrate data from multiple different systems within various departments to create a unified view of their data. Initially, we started with hearing more of a focus around the GIS and work and asset management use cases, but as new systems have continued to be adopted, and really the need for integration has grown within the industry, the desire to have connected systems has expanded beyond that into a whole host of other systems. Some might include customer information systems, outage management systems, and all sorts of other homegrown or commercial systems. Beyond that, they're wanting to take all of that integrated data from these different systems and then provide that to the business side within a BI application to then be able to visualize that data, have unified reporting, and in turn make better data-driven decisions. So when we think about all of these integrations, the choice for organizations really in the last decade had initially been to use internal development resources or start large development projects to build these integrations with custom code. Geonexus redefines the custom code approach to integration by providing a fully supported, easy-to-use, proven platform for system integration with an easy-to-navigate user interface to simplify the configuration and management of all of those various systems I talked about in the previous slide. This allows integration to then become more of a mapping than a coding exercise for end users. So there's really three core components to the Geonexus Integration Platform. The first I've already touched on lightly, which is simplified configuration. So within the platform, we provide that easy to navigate user interface that quickly connects your enterprise systems, allowing you to set up your configuration using a series of drop-down menus. This streamlines integration setup, maintenance, and management throughout the entire lifetime of the integration. This also allows additions or modifications to be made on the fly with little to no code required. The second is automated synchronization. So once the configuration is complete, we help you automate and schedule your synchronization on a specified task. If you have a system of record established already, or would like to set one, we can also synchronize your data bidirectionally as well if you'd like. The last is going to be active reporting. So once you've configured your integration and you have your synchronization running on a schedule, we provide in-depth reports to show that everything has run as intended. Some of the benefits our reporting can provide are detailed descriptions of any errors, orphans, discrepancies, and more that may have occurred. For sake of time, we won't be going into reporting within the demonstration today, but our last demonstration on migrating from GN to UN is on our website and shows reporting more in depth if you're interested in learning more. How we simplify integration even further is through our library of connectors you can see on the screen below. Each one of these connectors understands the unique business logic of each system and are constantly upgraded to allow you to take advantage of the latest and greatest system features with no fears of software version lock or downtime. This also includes data housed in a SQL or relational database as well. So now that you've heard a little bit about Geonexus, we'll dive right into the demonstration.
All right, so thanks for the handoff. So for this demo, I wanted to demonstrate how easily the platform supports multi-point integrations. So the out-of-the-box nature gives the user flexibility on how to structure their integration while mitigating integration challenges by having this easy-to-use platform with this fully configurable user interface, and not to mention, the scalability aspect is huge. So many of you may be familiar with the layout of the Geonexus Integration Platform and the user interface, but for those of you that aren't, I will take a few seconds to kind of set a baseline. So there's a couple main components of the integration with our platform, which would be mainly the configuration aspect and the automation aspect. So what I'll be going through today is the configuration aspects. So I'm going to talk about the project folders and the concepts of those a little bit later, so keep an ear out for that. But for now, we're going to open our water project at the top of our table of contents. And so just to go through quickly to, again, set a baseline. First, we have our console window, and this is how we could run the synchronizer manually, or alternatively on a scheduled task. And then we have our reports tab, which is where all of our PDF reports are shown here, and that shows summaries of each synchronization. And then after that, we have our data sets and other configuration aspects below that. So configuration of the platform flows in a few straightforward steps, beginning with configuring the top-level system connections. We can see that we have a Maximo REST connection, an Esri geodatabase connection, and then an Esri UN connection. These connections are easily established with login credentials and host URLs and some other basic information. And now once these are established, we can then move forward and configure data sets, which are comprised of data sources and mapping rules based on how features and entities align with each other, and then what data and fields you would like to synchronize between those entities. The first data set in the configuration here, this one's called GN to UN, Water Device Control Valve. And so this data set will be used to both load data from a geometric network to the utility network, as well as keep the features aligned while the organization migrates to the utility network. If we look closer at our data set, we can see that we have a source geodatabase data source pointing at a control valve table or feature class. And then we also have a UN water device target data source. And so we can see that we've picked these different values in our dropdowns. We're pointing at our control valve asset group within our water device layer. And then we could also choose an asset type in the dropdown, or potentially add several to this where clause if you wanted to point out several. But for now, we're not choosing an asset type. We're just picking a where clause with this text value in here. So if we go back to our water project, we'll now be looking at our second data set, which would subsequently run after the first one we were looking at. So if you remember from before, my first data set creates and updates water control valves from a geometric network to the utility network. The second data set, labeled UN to Maximo water device, would do just that. It would create our UN water devices or control valves and create those into Maximo. So if we look a little bit closer here at our we can open our UN data source. And this should look very similar to the one we had, in our last target up in our first data set. And then we look at our target Maximo REST data source. Again, very easy to configure. All you do is pull in your connection name that we created up in this beginning connection section here, and then you would just point at your Maximo entity, org ID, site ID, and then our classification. So moving down to our mappings here, which is kind of where the magic happens, we can look at our target mappings for creates. And this contains all the information and including required fields as in required by Maximo, to send to Maximo on creation of this record. And so, using this kind of two-step synchronization, we can actually take this updated structure that we created into the UN and load those into Maximo with their kind of updated hierarchy and schema. And so before I run out of time, I promised I would touch on projects within GIP earlier on. So projects are a way to essentially delineate different configurations within a GIP. So within the same user interface, we have this ability to, manage and run totally different configurations all within the same user interface. So if I open up my top project, I labeled it SQL Hexagon. We can see that, we have an entirely different setup here, as in it has its own unique console, has its own unique report section, as well as connections. And so, as you can probably imagine or may be living yourself, many organizations we work with have lots of different types of data stored in, or maintained in various locations or containers, if you will. So as shown here in my SQL Hexagon project, even data stored in a non-spatial table, so if I set up my RDBMS connection and I have that as my data source, even data that's just, in a data warehouse or a data lake somewhere stored in a SQL or Oracle database, we can touch that data and bring it to any of the other systems within our landscape. And so this really backs up, the claim that we are able to grow with your organization as you guys grow and adapt to your customers' needs and your own data changes within your organization. This configuration really focuses on creating data from, like I mentioned, an RDBMS table, and then bringing that into Hexagon EAM. And so I think we have a webinar that goes into a lot more detail about our Hexagon connector. But hopefully this kind of gives a little bit of an example of, through our management of our data sets and how configurable those are with our kind of separate projects that can be run, simultaneously. They can be run on different times with different task managers, yet kind of packaged up nicely in one location. Hopefully that kind of shows how we can support those multi-point integrations and as well as scale with your company as you move. There are a lot of more features to show, but unfortunately a limited time. So if you have any questions, please feel free to put them in the chat or just reach out to us directly.